it's live now.
Tap. Right.
All right, the microphone is live.
All right, so hopefully this works. This is the Leo that we all got, playing Flight of the Bumblebee.
Might be a bit close.
It's a bit close, isn't it?
Might end up being super loud.
Can you hear that?
Try putting it right underneath.
So there you go, music can be done. I'll have to work on this later.
Mark, you're up?
I'll make the slides afterwards, but I can do something in the meantime.
Okay.
Oh, is he gone? Wait.
Oh, no, couldn't get it working.
Oh, okay, so I guess I'm next. If I can do any better. Yeah, 'cause it's kind of a fun stuff on the screen.
Need some VGA?
Yeah.
That one?
Yeah.
Is the projector awake?
I'll probably use something to make it work.
All right, it's unmuted, ready to go. And the gain is turned up high. Are you ready to
Do I
go?
have to drag that across now?
You should be able to make them the same display.
Oops. Fail. Oh, that's a shame.
Yeah, so just another idea my daughter actually pointed out I could tell you guys about. There's a United Launch Alliance and Ball Aerospace in Colorado have a summer internship program, and what they have, they have the interns do a bunch of interesting things, but the most interesting to me is they have them design and build substantially larger than even what I normally play with, high-power rockets, and go fly them. For those of you who know the motor codes, the two-stage rocket they built last year, the booster had 2 in, as in Nancy, class motors, and the sustainer had a 3rd in. And this thing was 8.5 meters long and just shy of a half meter in diameter, and it's a big, big rocket. So the fun thing that they do is, because what United Launch Alliance is all about is working with other people who develop payloads for the big rockets and getting those integrated, they decided that a good way to model that with the interns was to have them work with high school and middle school groups to have them put payloads together and then go through the process of integrating with the launch vehicle. So these large rockets they build actually have a number of payload tubes sideways mounted in the airframe that are 98 millimeters in diameter and about 155 or so millimeters long. And each one has a piston at the back end with a pyro charge, so that when they reach apogee, they put out the first set of parachutes to stabilize the airframe. And as soon as it's stabilized, they've got a timer that fires the charges, and every second or so pops out another payload, and they carry a dozen or so on the airframe. And so it's amazing to be at a launch site where you normally have a club launch and maybe you get 20 or 30 or 40 people to show up for the rocket launch, and have 350 people show up because it's all the families of all the kids involved in the different high school teams and so forth. And the hoopla around all of this is sort of amazing. The reason it's related here is that last year, I think of the 17 or 18 total payloads that were built and flown, more than half of them had an Arduino in it doing something. And the project that my son and his middle school cohorts have me helping them with this year is sort of intended to be a little bit of an alternate energy exploration thing. They're going to put a little wind turbine at the end of a tube up the center of the airframe in the little payload thing they're putting together, and some solar cells and so forth. And we'll have an Arduino logging data and probably one of my new teleshield boards, so that we're actually getting live telemetry from it as it descends. So I don't know, maybe next year this time I'll have a cool little video snippet of how that all turns out to show you. The launch is scheduled for July 28th in Colorado. If you should happen to be in the right hemisphere, let me know and I'll tell you where it's going to be. Thanks.
Thanks for that. Do you want to say something just before?
Yeah, it's very quick actually. Actually, a quick question I forgot after my talk is, so not only if you know how to flash an X-Mega, you can talk to me, but the other thing I've been trying to work with is, I don't know if you've ever seen those, the SpO2 sensors in hospitals. They cost about $10, but they're really, really hard to talk to. If you have ever found anything that talks to that, or knows another one that can be interfaced in Arduino, please talk to me. Thank you.
Okay. Thanks, Mike. Are you ready to go, Luke?
No, I have no luck getting the right kind of Apple display
Okay.
adapter. There are about 40.
Is it HDMI or VGA?
VGA.
Get a ThinkPad.
Can you put it on a USB cable?
And before you flame, all I want is a picture of the pedal board on the wiki page, so we may be able to.
How about I pull that up on mine? Let's see what we can find. Oh, and also, that picture that's on my desktop, Mark Jessup, who spoke earlier, this is related to a project that he did. This was the Tuxeid space from last year, for anyone that's curious about that picture. So that's Tux, I think at, was it about 32 kilometres altitude? Somewhere around there. Is that what you need, Luke?
Yeah, that'll do. That looks good.
Do you need a laser pointer? I've got one of those.
Oh yeah, sure, because it's like blinky lights and lasers and things, and that's always good.
Oh yeah, you got one here.
Smoke machines, yeah, definitely. So the audio's on now, yes it is. Cool. No laser pointer.
No laser pointer.
Oh, that's not fun. It's just all.
Back to space, you've got to pick what laser pointer.
It's all right. No, that's.
Hold it together, otherwise it falls apart.
The instruction was hold it together, it will fall apart.
Let's see.
Other way.
Other way? Oh wow, this works. So I was going to do this talk earlier, but it didn't get scheduled properly and we ended up being a bit disorganised. I'm just going to talk about the hardware aspects of the Pebble board.